Hello, the video for this week is all about atoms and bases. Acids are compounds that tend to be reactive. They have a loose hydrogen ion, so they typically are a compound that starts with hydrogen where the hydrogen splits off. If you think about it, a hydrogen ion is just hydrogen and it's lost its electron. It didn't have any neutrons to start off with, so it's just basically a single bare proton that's wandering around, which is why it's so reactive. Acids tend to be substances that can sometimes taste sour, even a lemony kind of taste. They often react with metals. Whereas bases are the opposite. Bases have a hydroxide ion usually, which splits off, and that also makes them reactive to the hydroxide ion, can attack water, and and it's also reactive. So what tends to happen with bases is that bases tend to be bitter and soapy. And all of them, whether it's an acid or a base, if it's a strong concentrated acid or a strong concentrated base, they will react and attack your skin, which is why we need to be careful, and not just your skin, but they'll unblock drains and things like that. So all acids have these hydrogen ions that split off. So they start with an H atom. So you can easily identify an atom because it starts with an H atom. I'll just put these T's better. All bases have either a hydroxide, which is an OH, and also carbonates can be bases, which is a CO3 group. And most compounds don't have this hydrogen or this hydroxide, but they are still classified as something, and they're called salts. So most compounds that consist of a positive bit and a negative bit are called salts. And if we go down here and have a look at the activity that we need to do, you can see very clearly here that it starts with an H, so it's got to be an acid. Starts with an H, so it's got to be an acid. If I go down to this one over here on D, that's NaOH, that ends with OH, so it's got to be a base. So has that one over there. And ones that don't end in OH or CO3 or don't start with H, they're the ones that are the salt. So that's a salt. That'll be a salt too. I'll leave you to fill the rest in. If we look at the pH scale down here, we'll notice that 7 is the middle, and at 0 I have the strong concentrated acids, and at 14 I have the strong concentrated bases. So strong concentrated bases and at this end the strong concentrated acids. So the closer I am to 7, the closer I am to being neutral, which is what pure water is. The further away from 7, the more acid. So it gets more and more acid all of the way to 0, which would be the strongest, most concentrated acid, such as concentrated sulfuric acid or concentrated hydrochloric acid or concentrated nitric acid. And away down the other end, I get my weak bases and then my strong concentrated bases up the end here, and 14 would be where I'd see things like sodium hydroxide, potassium hydroxide, the really nasty concentrated bases that are used as drain cleaners and oven cleaners and things like that. Okay. Explain why acids have a pH of less than 7. I'm just going to go back to question number 5. The reason why they do is because when you're an acid such as, say, hydrochloric acid, as an example, would split in water into H plus and Cl minus, and so that there are lots more, go and have a look, lots more H pluses than in pure water, because most of water stays connected together. It doesn't divide up into an H plus and an OH minus. Okay, let's go down a bit here. And this is probably the most important question in the going further, and I'll leave you to do the other ones. The difference between a strong acid and a concentrated acid. And the key idea here is that a strong acid all of it splits up into H plus and the other ion, which could be Cl minus in the case of hydrochloric acid. Whereas a concentrated acid means there's lots of it in the water. It doesn't necessarily mean it's split up though. So if we go back to the pH scale above, if I've got a weak acid, even though it may be concentrated and I've got lots and lots of it, it's not necessarily going to have a very low pH. It's not going to be at the really bad end of the scale because most of it doesn't split up into hydrogen ions in water, whereas the strong concentrated acid would. And the less of the stuff I put in, the higher the pH, the closer and closer it's going to go back to 7, if that makes sense. So I could have a massive bucket of water and put a tiny bit of hydrogen chloride gas in, and the pH would be just below 7. It's still a strong acid, but it's dilute. There's not much there. It's not concentrated, it's dilute. There's mainly water. Whereas I keep on adding more and more hydrogen chloride to it, and it can go over this way here because it all splits up. Hope that helps you today when you're filling out this. We'll just go to the last page. If we go here, you'll basically see it's a fairly simple thing. Your substance you might be testing, for instance, is shampoo, so you write shampoo there. You find that shampoo's pH is, say, it goes a yellow colour, then you might write the pH as being 6. I don't actually have my pH chart with me, so please check that I am saying the right thing. It's fairly obvious by looking at your pH chart whether I'm saying the right thing. I think in fact yellow is an acid colour, but I don't have it in front of me, so double check your pH chart. But that's the basic idea of filling in this experiment. Hope you have fun this week.